All right, so we've been introduced to the general idea of solving the basic puzzles of our work a few weeks ago or last week. I don't know what it is because I try to be ahead of this stuff. But I do know that in class we just talked about this where we discussed whenever you have x plus 5 equals 18 and you're trying to find the value of x, the first thing we want to do is determine what we are doing to x. And in this problem, we are adding 5 to x. And so anytime you want to solve the puzzle, in order to get out of a room, for example, if I'm standing here and I go 1 blocks up, then in order to get back to where I belong, then I must go 1 down. In other words, the opposite direction. If I am standing here and I go 3 boxes to the right to get here, then I must now go 3 left to get back to where I was. So in terms of the basic one-steps problems, that's really what it is. So you have to think about if I was standing here and I added 5 to get to 18, then what I want to do is the opposite of adding 5. And remember that plus and minus are opposites. So what you can do, and I would recommend you do this on the paper as I'll show you in just a second, is work on it the way we kind of introduce in class, which is the opposite of adding 5 is subtracting 5. So subtract 5 from that, which of course gets rid of it because 5 minus 5 is 0. And then subtract 5 from your target, which is 18. Your x will come down. Again, that stuff cancels out because it's gone, and 18 minus 5 is 13. That would be your answer. Same thing on this. That's what we want to know, but we subtracted 7 from it to get to 12. Well, if we want to know what that originally was, we must say, well, if we subtracted 7 to get to 12, then let's add 7 because that's the opposite direction to both of these numbers. X comes down, 7's are gone, 19 is your answer, and that's all it takes. It just comes down to your ability to identify what we're doing. If 6x equals 30, we have to be able to recognize that this is 6 times x because there's no operation. Just like whenever we did 2 times 3 and there was nothing there, or we did 3 parentheses 6 and there's nothing there, same thing, that's multiplication. So this is 6 times x, which means we took some number we don't know and we multiplied by 6. Well, what's the opposite of multiplying by 6? That would be dividing by 6. So again, the 6's go away, we can just trust that, and 30 divided by 6 is 5. And then here what we learned is that that line means division, so it's x divided by 2. And what's the opposite of dividing by 2? Well, I usually use a parentheses for multiplication, but times 2 is your opposite. The 2's will go away, just trust me on that, and then 7 times 2 is 14. So this problem here just puts the original logic problem that we had together with our work with actual variables. The idea is still the same. We're going to start with the line of information we can figure out, and then we'll substitute and go from there. It is supposed to make you think, so take your time, and things do work out. It just looks difficult because there's a lot of stuff going on. But like I said, outside of that, you have what it takes. Remember I told you about your critical thinking things. You have what it takes, but you've got to make sure you don't just allow fear or something like that to make you just stop before you can actually get to the answer. So anyway, looking at this line here, 2a plus c is 12, 3a is 15, 3a plus b plus 2c is 25. Again, this looks intimidating, but if we know what we're looking for, which is a line that only has one piece of information, it's that one. So if you want to be responsible, I would go off and put 3a equals 15, and then I would use what we just did. If 3 times a number is 15, then I want to divide by 3 on both sides, getting a is equal to 5. I now have an answer. So I know that a is equal to 5. The next thing I want to do is say, okay, now that I know a is 5, this line doesn't help because I've still got 3 variables, but this one does. So I come over here and I will write, again, this is me being responsible, 2a plus c equals 12. And then using what we did in the first chapter, which is if a is 5, then we substitute 5 in using parentheses. So 2 parentheses 5 plus c equals 12. Now simplify what you can. 2 times 5 is not what we would say. 2 times 5 is actually 10 plus c equals 12. And here's what we have to realize. The c is having 10 added to it to make 12. Well, if 10 is being added to make 12, then the way we offset that is by subtracting 10, finding out that c is equal to 2. And there's our second answer. Again, I circle it because that's important information. And then the last thing I'm going to do, and I could just use this here since it's on the bottom anyway, is I'm going to take these two things and change what I can. 3, a is 5, so 3 parentheses 5 plus, I don't have b, so leave b as b, just make sure you don't view it as a 6, plus 2c, which is 2, equals 25. And again, now it just comes down to patience. This doesn't look right, so we'll turn that into 15. This doesn't look right, so we'll turn that into 4. Again, there's a lot going on, so what we can do, because these two numbers actually exist, is we can put those two numbers together. 15 and 4 turn into 19. Again, just kind of simplifying. And now we can do it. If we added 19 to get to 25, then let's subtract 19 from both sides to get to b is equal to 6, and those are my 3 answers. So it does take work, but it's not extremely difficult work. I think it's just, again, it's patience, and it's just trusting your instincts and going where you need to go. Looking at the second one, once again, we're looking at the line where we can actually solve, and to me, it just so happens to be the second one again. 5p is equal to 35, and so I go up and I put 5p equals 35, and I work my way through it. If 5 times p is 35, then that means I will divide by 5 to figure out the first answer, which is 7. I then have to find the one that only has 2 variables, because notice even up here I started with the one that had 1 variable, then I went to the one that had 2 variables, and then I went to the one that had 3 variables. Same thing here. 1 variable is p, 2 variables is this one, so we put n plus 3p would be 7 equals 26. Again, let's simplify this. 3 times 7 is 21. And if I'm adding 21 to get to 26, maybe you can do it in your head, but if you can't, just subtract your 21 to get n is equal to 5. I also would suggest not doing it in your head yet, because next chapter you do have to show all the work. So what we're working on is trying to get you ready for chapter 2 as we kind of work through chapter 1. But anyway, that was your 2 variables. Now we take it up to our 3 variables, which has m, which we don't know, plus 2n, which we know to be 5, plus 3p, which we know to be 7, equals 34. And once again, it's just patience. This can be turned into a 10. This can be turned into 21. These two numbers can be turned into 31. And now we have something plus 31 is 34. So again, how do we figure out what that is? Well, we do the opposite of adding 31, which is subtracting 31 to get m is 3. And that is our stopping point. It looks like a lot of work, but I want you to think about it. This wasn't that difficult if you've been keeping up with, again, that's multiplication, so we divide. This isn't difficult if we remembered how to do that first chapter stuff where we simply substitute what we know using parentheses. You simplify it, and again, subtracting 21 is not a difficult thing. And once again, taking our time from what we've learned, plugging 5 in for n using parentheses, plugging p in or 7 in for p using parentheses, turning 2 times 5 into 10, 3 times 7 into 21. It's a lot of steps, but I don't think any step is really difficult. So again, if you're still having an issue with this, please make sure you talk to your teacher. If I am your teacher, then please talk to me. But outside of that, have a good day, and I will talk to you later.